Alright, welcome to the 8th requested video, and it's actually a bunch of requested videos, I don't know, maybe like 2 or 3, because we are going to answer a few requests in this video. And these are going to be at first, how to change the window icon in the top left of the window. Well, I mean Firefox is a better example right now, but anyway, we're going to answer this one. Also, we are mostly going to talk about the player animation, in the example of the tiled map game series for LibGDX. So in that project we are going to implement this, some player animation, and I think that's actually it, I guess. So let's just go ahead, and I already did some stuff here, never mind. So we're going into the Blackpoint 2 thing here, project, and we want to add some icon to the top left of that. So let's go ahead into the desktop project and make sure that you have some icon image there. I already put it in, but of course you need some image to set as icon, otherwise that makes no sense. Then the only thing that you've actually got to do, it's pretty simple. Just go into the desktop starter and say configuration.add icon, and that's actually it. So we have to give it a string. It's an image icon.png, and then it takes a file type. That's from like the usual file stuff that you know from gdx.files, and then you have internal. So that's the file type that we want. So we say file type dot internal, because well, it's an internal file. And that's actually it. Let's just start this up, and we're gonna see that there is going to be this super awesome color icon here in the top left corner of the window, just usual. Maybe you can see it here better. But anyway, that's actually it for this whole request. So we are more or less done with this. Alright, so now that we got this covered, we are going to talk about the player animation sorry, on the example of the tile map game series. So we don't need this anymore, and there we are, the tile map game series. Let's just have a look at what's happening, if I'm already setting that correctly, or if I'm setting, yeah. So okay, I can show you what we're going to have at the end of this episode. It's going to look something like this, where the player walks around being animated left and right, and when he stands he's nodding his head. I don't know, he's listening to some music in Pokemon or whatever. Alright, so this is not going to be the test, this is going to be the real thing. And yeah, let's go ahead and modify a few classes. At first we want to modify the player class. Actually no, let's start by making the animation. And yeah, to actually make this animation we need a bunch of images, because an animation is made out of a bunch of images. So let's go in here, and you see I already did all of this, but let's just rename this folder to player test, and we basically have nothing anymore. So you are lucky if you have an image like this, which I also just added, where all these frames are already arranged. So in case you have the frames all in one image, there's a way to do it, and in case you don't have them all in one image, there's a way to do it. Let me first explain the way how to do it if they are all in one image. Alright, so to do this we need to write such an peg file to define the regions of the image, which are the frames. So let's just go ahead and get one of these peg files. Unfortunately this is exactly the peg file that we want to get in the end, so I need to get some other peg file, like for example this project UI atlas.peg. You probably have one flying around. Just take that, and we're going to modify it exactly how we want it. So this is going to be player test.peg, and this is going to be player.pack. Even if you don't got one, it's really simple. Basically all you have to write is... oh, wrong editor. Open with text editor. So basically all you have to write in the beginning is these 4 lines. Make the first one free, then write the name of the file, which is actually going to be player sheet.png. Write this format stuff, then the filter that you want for, I don't know if this is min or mag, but whatever, you probably want the same one on both ones. So nearest nearest, or linear linear, or linear nearest nearest linear, however you want it, and repeat. I don't even know. We don't care right now. So we just want to set the regions of this image. So let's open up this image in actually Paint to see where these regions are. So there's the player sheet, and open it up in Paint. Yes, open it up in Paint. There we go. So now we can see where the regions of the specific frames are. Let's just start with the standing still animation, and the first frame is, if we just look like this, that was actually not correct. The first frame is, well, who cares? That's correct. The first frame is actually oh, I'm sorry. We wanted 20 times 20 pixel region, just like that. So here we see 20 times 20 is the dimensions, and it's at a position where we can easily see that it's at position 0, 0. So that's the info that we want to put in here. At first, the name. The name is going to be still. Hello. Still, because he's standing still, not rotating or anything. XY is the position, which is at 0, 0. The size is, as we can see down there, 20 times 20. And the origin, we are just going to set this to the middle of the sprite. And the index, it doesn't really matter in case you want the sprites in a specific order when they play in the animation. You could set this index to 0 and then the next one to 1, or maybe this one to 0 and this one to 1, so that changes the order in which they are actually played, but I don't care because they are fine in whatever animation they are played. So then we're going to add another one, actually called still as well. You can give it the same name as the first one. And well, because every of these sprites is 20 times 20 of these frames, we don't need to do this one again and this one again. We just know it's always 20 times 20, so yeah, that's perfectly fine. 0, 0 plus 20 on the x-axis makes simply 20, 0. So that's it. For the size, 20 times 20 again, and the origin 10, 10, and that's it. Actually, let's get rid of all of these and just copy this thing here so we can easily modify it. There's a third frame for the still standing animation, and yeah, no, actually let's just make the still standing animation 2 frames. We can do that as well. But we want the next animation, which is the one if you're going left. So we see these 3 left going guys here, and this is the first frame of that animation. So we have to see the x and y values, and we know 20 plus 20 plus 20 makes 60, 80, 100, wait, was that correct? 20, 40, 60, 80, 100, 120, 140. So this guy is at 140. Oops. And first, this is the first frame of the left animation. he's at 140, and this is all the same stuff. Then we've got someone of the left animation again. He is at 160, and the same is, yeah, the rest is the same. Then the next one, also of left, make sure to have this 2 spaces here and no space here. I guess it would mess up otherwise. So 180, 20, 20, fine. Now let's just get the ones for the right animation. And we can just continue this because they are over here. Always 20 times 20 again, so right 100, actually 200. Right again. This is 220. And right again at, oops, 240. So there we go, we have our player.peg atlas, and yeah, that's actually it. So we don't need this anymore, but this was just the way. You're going to see why this atlas and everything is needed in just a second. But in case you don't have all your images on one sheet, you probably want to put them all in one sheet and get this atlas file generated automatically. And you can do this with the LibGDX texture packer, which I already introduced in an earlier episode. But let's just repack this image with it. So let's actually go in here and delete these 2 files here. So these are just exactly the same images that we just defined in the player.peg file, but as single images. So I can show you, just like this, every single image. So we want to pack them in one sprite sheet and get this atlas file for it. And where's actually the texture editor? It should have started up. I mean, sometimes it's taken a long time, but this is a really long... Oh, see, it's really taken a long time. Okay, so let's create a new pack called player, and we can edit some options here. I don't want to force the power of 2, you probably want to. And the rest is fine with me, that's fine with me, that's fine with me. I don't want any padding. I want to save some space, and the JPEG quality should be 1, and whatever. So as input directory, I'm going to take this directory here, player test, because that's just where I happen to have all the sprites saved. So on documents, Eclipse, I think it's right there, and assets. Hello, I clicked on that. Image, player test, and yeah, you don't see the images, but they are there. The output directory is not going to be player test, but instead simply player. And yeah, that's it. You could give some file name there, but we'll just leave it blank for packname.peg, and the pack name is player. So let's pack them, and he says he's done, and shows us the result. And the result is actually pretty fine with me, so we're good to go. So what did this just do? At first we have to refresh, and there we see the image.player directory was created, and inside there we have this player.peg file, which I open up with the wrong editor again. Oh, I actually didn't click. Cool. So text editor, and we see it's basically the same thing, but we're gonna edit some things, and that is we take these numbers off because they are the file names of the images, how I named them, and I can't name images the same in the same directory, but I can in here. So I just removed the numbers at the end of the name, and we're good to go. So there is this file that he generated, just like to let you know. Okay, so let's actually get to the part where we put that stuff in the code. The first thing we want to do is create these animations in code. So we go into not here, we go into the play screen. And what we want to do is we want to edit the player constructor, because right now the player constructor is taking one single sprite, and that is the sprite that he's displaying all the freaking time. Instead we want him to take 3 animations. So these animations are going to be the still, left and right animations. So where do we get these animations from? We get them from a texture atlas that I was talking about all the time. So let's go ahead and add one texture atlas, player atlas to this. Then we obviously have to create that thing in, actually in here. New texture atlas. And we can just give it the internal path, which is image player dot pack. Right there, image player dot pack. Should probably import the texture atlas, that would help a lot. Yeah. And don't forget to replace player.getTexture.dispose. Well, that would also work, but just because of coincidence. But we want the player atlas to be disposed, which just means, actually we can see it in the Java doc. This releases all the textures, backing all texture regions and sprites. Okay, so we got this texture atlas, and we can now go ahead and create animations from it. So there's going to be one animation for still, one for left, and one for right. Import that as well, and make sure to choose the 2-dimensional animation. Still is going to be a new animation, and this takes a bunch of things. At first, a float, which is going to be the time that each frame is going to be displayed in seconds. So this is going to be 1 divided by 2f for the still animation. Just figure that out yourself. The value, yeah, whatever, doesn't matter. If you are running at 60 frames, 1 divided by 60 would be the time for 1 frame. So 1 divided by 6 would be for 10 frames. 1 divided by 3 would be for 20 frames, I guess. And 10 is a little bit longer then. So this actually doesn't matter how many frames, actually. This is in seconds. What am I talking about? This is in seconds, okay? So 1 divided by 2 means this is going for half a second. And then it's taken actually an array of whatever extends texture region keyframes. And we can get these very easily from the texture atlas. So player atlas dot find regions, which takes a string, and that's why we named all the frames the same, why we gave them the same name. So we can just say still, and this find regions method is going to return all the regions of the texture atlas called still. And if we just have a look in here really quick again, we see that there are 2 ones. This one and this one. They have the same name, so they are both going to be returned by this, actually in an array, as we can see right here. So this is going to create a new animation for still, and then we want one for left. What am I doing? Left equals new animation. 1 divided by 3f. I want it to be some, actually no, 1 divided by 6f. And the keyframes are going to be player atlas dot find regions left. Right equals new animation. Also 1 divided by 6f. And player atlas dot find regions right. All right. Ha! What a great joke. We we can now pass them into the player constructor, which still is the same constructor as before, so we get a nice little error here. But let's just go into the player class and change it to what we want. So where's the player constructor? Right here, I don't see it. Ah, there it is. We don't take a sprite anymore, but instead we take 3 animations. So animation still, animation left, and animation right. Import the animation, and we're going to call a super constructor, which takes a sprite. Actually, you can see right here, it takes a sprite. So where do we get this sprite from? Yeah, very simple, just still dot get keyframe at time 0. So simply what it all begins with. Then we want to store these 3 animations, like, I don't know, let's say right there, private animation still left right, and assign them. This dot still equals still, this dot left equals left, this dot right equals right, and there we go. We have these 3 animations in the player class, so we are ready to use them. Alright, so let's go ahead and use them actually. So there's one more thing that we need, and as you can see right here, the animations work the following way. Let's take the still animation, and there are just these get keyframe methods. There is nothing like playing stuff or blah blah blah, or drawing or whatever. There's just get keyframe, which returns a texture region, and that's it. So we have to manage the timing and what should be drawn at which time ourselves. The animation just tells us for the settings that this animation has and for the texture regions, which texture region to display at a given time, but we have to give him this time. So yeah, you see it takes a state time variable, which is a float that we have to define. So this is going to be the animation time, starting at 0 obviously. Alright, so let's go down here, all the way down to our update method, and just say update animation. The first thing we want to do is to take the animation time and add the delta time to it. So, oops, yeah, the animation time. So the animation time is now always counting up by the amount that passed since the last update. Then we actually want to set the animation to whatever it just is. So we can just simply say set region. Actually, why set region? Which takes a texture region. Yeah, if you have a look, still dot get keyframe also returns a texture region. So we just assign this texture region to this player, which extends the sprite. That's where this set region method actually comes from. And yeah, this sets the current frame to the player. So we don't just want to say still dot get whatever. We need to decide which animation to display at what time. So we have 3 animations, still, left and right. So guess when what is going to be displayed? You got it. Still is going to be displayed when the player is still, left when he's walking left, and right when he's walking right. So when is this? When is the player walking left? You see the velocity variable right there, and basically everywhere else the player is walking left if the velocity on the x-axis is smaller than 0. So in case velocity.x is smaller than 0, we want to display the left animation, so left.get keyframe, and now it takes the time, which is animation time. And well, in case that's not, in case velocity.x is not smaller than 0, we want to check if velocity.x is greater than 0. And if that is the case, we are going to the right, so right.get keyframe, animation time, and oops. And in case the velocity.x is not smaller than 0 and it's not greater than 0, it has to be exactly 0, so we can just say still.get keyframe animation time. Alright, so this looks a little bit confusing, but it's actually pretty simple. So if we're going left, we are taking the correct texture region out of the animation for going left. If we are going right, the one for going right, and whatever, you know what I'm talking about. And then we just set this to the region of this sprite, so of this player, because the player extends the sprite. And the next time the draw method of the player is going to be called, this specific updated region is going to be drawn. Let me just think a bit. Yeah, that's not actually all that we need, but we can already run this. Yeah, we can, but it's not going to be perfect. So let's just run this for fun. And there we go. So you see the player is obviously updated a little bit with animation, is he? Yeah, I don't know. I don't know if you can call this animation. Alright, so let's just go ahead and make some stuff better. At first, we want to go into the key down and key up methods, and look right here. If keys.a is pressed, we set velocity.x to minus speed. So this means if keys.a is pressed, we're going to the left. But if we're going to the left, we don't want to we don't want the animation time to continue. We actually want it to be reset to 0 again, because we want to start the walk-in left animation over again from 0. So animation time equals 0. We want to do the same thing when he goes to the right, and we actually want to do the same thing when he stops. So the still animation is going to be reset to 0 again. And now we can probably see a little bit of animation right there. Watch out, it's over fast. Yeah, he makes one step and he makes one head nodding there, and then he's actually done. So why does he stop in the middle? Well, that's a pretty simple reason. Let's just go back to where we create these animations, and we're going to see that the animation class has a set play mode method, which takes an int that we get from animation dot what do we want? Loop ping pong, loop random, loop reversed normal, reversed blah 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 blah. We want loop. Pretty classic. Left, and what is that? And right. So we always just want to set the play mode of the animation to loop. So we have to restart this, I guess. Yeah, we have to restart this. Actually, let me just get rid of these two tabs that just confuse you. So now that we set this to loop, the player is walking continuously to the right, continuously to the left, and is continuously head nodding. Yeah, right there. So this is how to animate a player. I guess this episode became way too long, exactly. But thanks for watching. I hope I cleared some animation questions up here. And yeah, the animation class is actually pretty awesome. But okay, since this episode is already long enough, we can take care of one more thing. And that is actually the collision detection. I know this now seems like, oh my god, he wants to touch the collision detection, it's just working fine. But yes, I want to touch the collision detection right now. Let's just say we make... Okay, let's just have a look at this. What's with this? We're doing the same thing over and over again. Right here we have contains key blocked. Right there we have contains key blocked. We basically have contains key blocked everywhere, and that's not a good idea to repeat code. It's never a good idea. Just imagine I wanted to change this blocked, for example, solid or something. I would have to change it in every single place, and that is obviously not good. So we just want to take one of these block things here, dot get tile.getProperties.contains_blocked. Just take one of them, and yeah, we don't care about the error we get right there right now. And we'll just go down here and create a public, or actually just for, I don't know, private boolean is cell blocked, and that's taking a cell. So this can do the work for us that we've been doing all the time. It's just going to return if cell.getTheTile.getProperties.contains_blocked. And actually we can do some more. We can say if cell.getTile does not equal 0, does not equal null, so if there is a cell in the tile, and then cell.getTile contains property blocked. So if we're walking over a place where there is no cell, we are going to get no error. It's not going to crash, no null pointer exception. That's already great, and we are taking this work away from us. Also, blocked could be replaced by a blocked key string that we put up here. Private string blocked key equals blocked. So this saves us some work. Yeah, now this is kind of not working anymore, right? Right. At first, let's get rid of all this unnecessary work that we did. We don't need this here. We don't need this. We don't need this, and we don't need this, and actually you could do it for all down there as well, but let's just continue here. We're going to add one more temporary variable called tempCell, or whatever you want to call it, and yeah, do some stuff. We want to check. Actually, what we want to do, I think we can do it all in one line. That's cool. If you can do things in one line, I like that. So collision layer.getCell returns a cell, and we want to set this temporary cell. Actually, no. What am I doing? We don't need this. We can simply say is cell blocked, and that's it. That should actually be it. What's the problem right here? Is cell blocked? Oh, there's no problem right there. Cool. So we just say is cell blocked every time and put the cell in that we get from there. Is cell blocked. Blocked. And do this in all the places. Yeah, this is really fun. Let me just copy this and oops, paste jup drp over here. Jup. Alright, and now do this for here as well. Why didn't I copy this parentheses with it? And now to the other side, remove the getTile.getProperties.contains_blocked and just replace it with one single parenthesis. Actually, a really stupid thing that I did there. Okay, so we are done. We now got this isCellBlocked method, which takes a cell and does just the same work basically as we have done up here already. Okay, so it should still just look the exact same. And yeah, it looks the exact same, and we don't see any difference. That's what we wanted. Actually, we can we do that? No, we don't care. Alright, so that's it for this episode. We talked about how to change the window icon and how to do some player animation. And we kind of did some basic Java method stuff. Alright, so thank you for watching this actually pretty long episode. Oh yeah, it's pretty long. So thank you for watching this, or just watching it partly. And I'll hopefully see you in the next one. Alright, goodbye.